Hi everyone! In this tutorial we are going to learn how to create viscous liquids with air bubbles. I'm going to use this tutorial to explain how do I approach any VFX project and my workflow before jumping to Houdini. I have been getting a few messages asking how do I start my projects and how do I know what to use in Houdini to make the visual effects or animations. So I'm going to try and explain the best I can the approach I do for any type of project I need to do. At the end of this tutorial, we will see how to render this animation with redshift. I hope you enjoy this tutorial. Okay, so I start every project with my friend Photoshop or a paper and a pencil, and I start drawing the logic and thinking about the logic before jumping into Houdini. So let's start with this project. So we want to create jelly, right? We know this is an arrow. This is a viscous liquid, right? So we know this is a viscous liquid, so we need to emit this liquid, okay? And we need to collide with our chocolate bar or with any geometry we have. Okay, so this is the basic stuff for the jelly. We want to add air bubbles, right? And air bubbles, if we think about them, they are little spheres of air that are inside our viscous liquid, right? So how can we do that in Houdini? We can emit particles, okay? Emit particles that will be spheres, okay? And these particles need, need to be inside our liquid, okay? Lucky for us, in Houdini, when we create liquids, we are working with particles, so we can use those particles to emit our air bubbles, right? So we need to use the particles from our liquid, so they need to have an ID so we can work with them. Okay, so we have our viscous liquid, we know we need to emit, we need to make them collide, the liquid collide with our chocolate bar or any geometry. We want air bubbles, so air bubbles are particles that are inside the liquid. We are going to emit particles, use the particles from the liquid. Those particles need to have ID. They can change the ID during the simulation, so they can't change ID, right? So, and after that, we need to subtract our particles from the liquid, right? Because our air bubbles are little space without liquid inside the jelly, right? So I think this is the main logic for our work. So we need to emit. Let's start by making this. Let's do this and then do this on the second part. So let's start by emitting liquid, make that liquid viscous and make it collide with something. So let's jump into Houdini and let's create, I want to create a tube. Okay, let's jump into, before that I want to change the name, liquid emitter. I want this to be a tube. We are going to emit our viscous liquid from these two. So I want on Z axis. That's cool. Radius scale, it's way too big, 0.1 maybe. And height, I made 4, 3. Okay. This is our base. Let's transform. Let's put it up. Okay. And let's place a null. Out liquid emitter. Okay. Now let's go up one level and let's use our shelf tools. So select this node, go to, instead of going to viscous liquids, we are going to liquids. Where are you? Rigid particle fluids. And let's press on emit particle fluid. Okay, Houdini is going to work for us and create every single node. It is asking now to select a fluid object to emit into. We don't have that, so just press enter. And voila, we have the dot network. Let's go up. So we have our emitter, our dot network, our particle fluid, and we can delete this one because we are going to render this in redshift. So we can delete this one. Okay. Let's go inside. I'm just going to clean up this and let's delete everything. Okay. Let's go up. So we have our liquid emitter. Houdini created as a flip source and then other nulls. Okay. We can turn off that. And our dot network, we have our flip object, our volume source. Everything is all right for us. So if I press play, you'll see our particles falling down. If you want to see this with colors, we can put how do you call it, particle fluid surface. We can see that with particles and use a velocity ramp. Okay, so right now we have our particles falling down. Let's go increase the resolution, in other words decrease the particle separation. For this tutorial I'm going to use 0.04. In my work I normally use 0.01, but that is way too high for me to handle the tutorial and the simulations. So I'm going to work with 0.04 and hope my computer will work with me. So right now, if I press play, we will see our fluids going down because we have the gravity node. Okay, everything is all right. So to start, let's put a ground plane. Okay, if we check the dot network and press L to organize, now we have our ground plane and our particles will collide with our ground plane. Cool, and they are behaving like water because we didn't change anything, and that's the default for Houdini. So let's start by making our viscous liquid. So let me change the color. So let's create, we are emitting liquid. Okay, so now let's make it viscous. This is so easy that it will blow your mind. So we have our emitter. We don't need to change anything here. We go to the flip object, and if we go to physical, we have here a viscosity. Pretty cool. So we can increase this to maybe 500, for example. And before we press play, we need to do one more thing. On flip solver, we need to go to our, let me remember, volume motion and turn on viscosity. Okay, on volume motion, we need to turn on this. If you have multiple fluids, you can add attributes to those points. So if you have like two fluids, one of them can have high viscosity and the other one can have low viscosity. You just need to put an attribute to control that. But in our case, we are keeping this simple because it's a start tutorial, an intro tutorial to viscosity. So let's turn that off. Just turn on enable viscosity, and this flip solver will use the viscosity attribute or the value you put on the flip object. Okay. One other thing I like to do with viscosity liquids is turn on surface tension. This will try, if you have a lot of water, this will try to make them more together, so it will be more like this and make droplets. Okay, it will look like this and this will look like this. Okay, this is no surface tension and this has surface tension. Okay, so we need to have this, so it's a little nice to have, let's call it nice to have this surface tension. Right now, if I press play, our fluids will behave a little bit differently when it collides. Let's see. So as you can see, it's not spreading like it was before. Now it is like jelly. But it hasn't that much viscosity as I want, because this looked like more like honey and I want it more viscosity. So this is the part where your art director says how it wants. So in my case, I just want to increase viscosity. I'm not working with density and any other values. We are just exploring the viscosity. As you can see, we can make anything so cool with just changing one attribute and turning it on here. Okay, don't forget, this is really important. If you don't have this, it won't work because our flip solver will ignore the viscosity. So remember, select the flip solver, volume, motion, viscosity, turn on enable viscosity. So I increased the viscosity to Jesus, to 1500, and I think this will be really viscous like we want. Pretty cool. It's starting to accumulate, as you can see. So right now this is kind of boring. We just have liquid falling down. Let's animate our particle emitter, so we will have those really cool effects when you drop jelly liquid above another jelly liquid. So what I'm saying is, let's go here. I'm turning off the other objects so we won't see that. Okay, so we have our emitter. Let's animate this. So let's start by making this not on C, sorry. Let's go -4. On 30, no, not 30, 60. Go to 4. Okay, so we have this animation. So now let's make it loop with just 2 keyframes. Check this out. Just press right click, motion effects, and let's go to cycle. It will create a few nodes for us, and as you can see, this yellow graph as a preview for our animation with just 2 keyframes. I'm going to show you that we will have this animation. Cool, but I want it to zigzag, so I want it to do this while going with the timeline. Okay, so instead of using cycle, let's change it to mirror. As you can see, the graph change, and right now if I press play, you'll see it will do a zigzag. Pretty cool. Let's do one more thing. Let's put a transform, another transform here. And right now I want to rotate our tube. So let's use an expression. I don't like to use a lot of keyframes. You can do this with keyframes, but I don't want that. So let's use an expression, and right now our tube will rotate while moving on the X. Pretty cool. I'm going to increase this. As you can see, with just 2 keyframes we add a bunch of motion. Let's increase this, maybe 200. Cool, cool. So we have our emitter moving. So right now let's check our animation. I'm going to decrease the resolution, in other words, increase our particle separation, because my computer is getting way too slow to record and calculate, process the simulation. But as you can see, we are getting that here. I hope you can see this. We are getting like 2 levels of liquid. This is the jelly and the viscosity parameter working. This is what we want. Pretty cool. So let me make this think. So let's go back. So we have our viscous jelly, we have our emit. Let's make it is colliding with the floor, but let's create a chocolate bar really quickly and make it collide. So let's go back to Houdini. That looks cool. Okay, so let's create our chocolate bar. So choco bar. Let's place a box. Okay, let me think. 0.2 maybe, and I want this to have 8, maybe more, 9, because our emitter is going from -4 to 4, so it's good to have a little bit more. And here I want maybe 5. That's our base for our chocolate bar. I want the chocolate bar to be on the floor, so let's copy parameter, paste relative, and divide it by 2. So our chocolate bar is always on the floor. And let's change it to polygon mesh. This one I just want to have 2. This way we are going to control those little cubes from the chocolate bar. Let's make it like 10, maybe 8. Yeah, that's cool. So right now let's group them. So let me think how can we group them. Group by expression. So let me think. So we can do like this. Use a position on Y, because what I'm trying to think and do. Let's go back to our Photoshop. So we have a bunch of polygons, right? And I'm going to use, sorry, this 3D drawing. So I'm going to use expression to select only the top primitives, the top faces from our box. Okay, I'm going to use an expression to ignore everything and group this top layer. Okay, because we are going to extrude those faces. So let's use this, and let's use a channel float, mean position Okay, so right now everything is selected. So if I increase this, now as you can see from the yellow color, we have only the top faces selected. That is cool. Let's use the node name, and I'm going to call them top faces. Okay, pretty cool. So now I just want to poly extrude, change this divide into individual elements. So right now, as you can see, everything is extruding. So let's select our top faces. So right now only the top faces are extruding, as you can see, and we can do an inset. Cool, right? So let's make our little chocolate bar. Pretty cool. Don't forget to change this to individual elements. If you have connect components, it will make the extrude as it was only one face. Okay, so always change the individual elements to extrude every single polygon. So right now let's polybevel just to smooth a little bit our chocolate bar. Pretty cool. Let me see this shaded. Okay, our chocolate bar is cool for now. Let's create a null out choco bar. Cool. And let's make this, let me turn off the ground plane, and let's make this a static object. So we're just using this shelf tool with choco bar selected, press static object, and you will see Houdini created everything for us. So now we have our choco bar here. Let's check if the geometry is alright. I like to turn off display geometry, and on collisions let's check the collision guide. As you can see, the division size is way too big because it is ignoring those details inside our chocolate bar. So let's decrease this to maybe 0.025. So right now, as you can see, we have every single detail from our chocolate bar. Pretty cool. Let's turn off this and let's go up one level. And I'm going to let this process, okay? And be right back. Okay, so here is a little flip book with our simulation so far. By now I can see we have the viscosity way too high for my taste. As you can see, this is getting way too much on top layer. So before going to the air bubbles, I just want to lower a little bit, reduce a little bit the viscosity. So let's go back to frame 1 and let's change this to maybe 1000. Okay, we saw that 500 was way too low, so 1500 was way too big, so we are going with the middle. So let's check our Photoshop. So we have covered the first part. Let's do the air bubbles now. So we have our liquid. Okay, we need to emit particles that are moving inside our liquid. So we are going to use the particles from the liquid. We need to do a group we are going to use a group to select a few particles from that liquid. Okay, we need ID, and we need to be sure that our ID is not changing during the simulation. Okay, then subtract our particles from the liquid. In other words, make holes in our liquid, and that we are going to use VDBs, volumes. Okay, that's easier to work with. So let's jump into Houdini and let's start with this. Because we are going to use our liquid, so let's add ID and be sure that they are not changing. So let's go back to Houdini. Where can we do that? I think it's on flip solver, on particle motion, behavior. Let's add ID attribute. Cool. And on receding, let's turn off receding. This is changing and creating particles during the simulation, so the IDs will change during the simulation. And remember, we don't want that. We need to be sure that our IDs stay the same. If a particle starts with ID 300, at the end of the simulation it will have the same ID. Okay, if we don't turn off the receding, our air bubbles will kind of jitter during the simulation because the particles are constantly changing the IDs. Okay, so we have everything. Let's go to particle fluids. Let's delete this. So we have our dope import. Okay, let's create a file cache. I like to work with file cache because my computer is little slow. So let's call fluid particles cache. Okay, as you may know, I'm going to delete the heap name, so I'm using this node name, the frame, and I'm going to press save to disk and be right back. Let's save our cache. So our cache is done. Let's check that, load from disk, and let's go up one level. Let's see. That's a cool animation. If you want to see and create the geometry, let's use for now, let's use VDB from particle fluids. Okay, let's use the same particle separation as our flip object. So copy parameter, let's go here and paste the same relative. Okay, so it's 0.04. Cool. And I'm going to reduce this voxel size 0.4. It's taking a little bit to process everything. So we have our base, as you can see from below. We can see the squares from the chocolate bar. Okay, cool. So one other way that you could create this geometry, we are going to use VDBs, that's why I'm using this one for now. And we can place a convert VDB and change this to polygons. So now we have polygons. Okay. One other way that you could see the geometry, if we don't want to use bubbles, we can just go with particle fluid surface. Okay, use surface polygon soup or surface polygons. Okay, so particle separation, we are going to use the same. Okay, and we have one more smooth geo. With this node, we can go to filtering and apply these smooth effects. Okay, but we are going to create air bubbles, so we know that we need VDBs. Let's change this to green now. So now we need VDBs, okay? Because we need to, along the way, we need to subtract the particles. Okay, so we have our particles. Okay, we have this particles with ID. They are not changing the ID. Let's now select and group our particles. Okay, so let's go back to our I'm going to leave this in case you are going to download the project. Okay, so we have our particles. Cool. So now let's select a few of them. Let's use a group expression. Okay, let's press this little arrow and let's select this one. Instead of being 0.3, we need to decrease this way too low. And the group type is points, not primitives. Okay, so as you can see, our points, our yellow points are the group ones. So 30% is way too high. So let's change it to really low. Okay, this will control how many air bubbles you want on your simulation. Maybe I'm going to stick with maybe more so we can see during this tutorial. Okay, I hope you can see the yellow points. Okay, if I press D and increase our size, okay, I hope you can see a little bit better the yellow points. Okay, instead of using element number, we are going to use the ID. Okay, because we are making a random and we need to be sure this seed will stay the same for each particle during the animation. So let's use ID, our ID. That's why we did this. Okay, because we are going to use the ID to group our particles and select particles to be the air bubbles. Okay, let's name it. I'm going to use the node name, and here let's change it to air bubbles group. Okay, now let's place a sphere and copy to points. Pretty easy. Okay, so right now it is copying to every single point, but we don't want that. Okay, points, everything is all right, and here we want the air bubbles group. So these will be our bubbles, and in real life the air bubbles don't have the same scale. Okay, so let's change that. Let's place a point wrangle and use a little bit of vex. You can use a point swap if you want, if you are more familiar with that. We are just going to change the P scale to fit. Oops. Let's use random, use the ID. The random changes from 0 to 1, and we want a channel float min size and a max channel float size. Okay, that's cool. If I press this little icon, now we have our points. So let's make something like this. Am I doing everything? Let's increase this voxel size, and I want this to be not 0.1, 0.05, 0.2, and here 4. That's cool. So we have a nice, let me check with our VDB if they are not way too big. So those will be our air bubbles. They look cool. So now let's go to the final stage, that is subtract our particles. Okay, so we are going to use VDBs. Okay, let's put this down. So we already have the VDB from the particles, so we are missing this one, VDB from polygons. Okay, Let's decrease this to 0.01. Okay, so we have all the bubbles. Okay, cool. Let's smooth everything. So I want to smooth here, and I want to smooth here too, and I want a VDB combine. VDB combine is a boolean. It will work as a boolean. Okay, so right now I want our main surface and I want to subtract our particles. Okay, let's change this to the other side so it will be easier to understand. Okay, so we are converting our liquid to a VDB, smoothing everything and making a boolean from our air bubbles. So right now, instead of copy, I want STF difference. I know you don't see anything. Oh, you can see here when the bubbles are way too close to the surface. Let me try and go inside. But as you can see, we are subtracting those bubbles from our volume. So this will be empty inside. Okay. So the final step is convert everything to polygons. Pretty cool. So we have our jelly, we have our chocolate bar. Let's place a grid to make our floor. Okay, so we have our floor, our chocolate bar and our jelly simulation. So one thing we are missing is render this in redshift. So we have chocolate bar, we have our floor. Let's change it to floor. Okay, let's put this here. We have our jelly fluid with air bubbles, and we have our ground plane. Okay, so I'm going to press with the mouse in this. I'm going to press Ctrl 1. So I'm setting a quick mark. I'm going to chop. Press Ctrl 2. So now if I press 1, I go back to object. If I press 2, I go back to chop. Here, let's place a redshift material. Let's call it jelly. Let's alt drag, call it choco bar, and let's make one for our floor. Okay, and we go to the out. Again, Control 3 in this case. So we have 1 object, 2 shop, and 3 output. Let's go to redshift tab and press redshift. Okay, so we have here our redshift. Let's go here and redshift. Let's turn on the global illumination. I like to use these settings to start. Okay, and here let's change it here like this. Okay, everything is set up. So let's apply materials on the floor. Let's apply the floor material on choco bar. I want the choco bar material in our jelly. Let's place our jelly. Okay, let's place some lights. If we don't place some lights, it will be dark. And we need a camera. So Control click the camera to have this viewport. Let's make something like this. I'm going to change my UI to my Doxia. Okay, I'm going to change it because I like to have 2 viewports, a parameter list. Let me show you. So now here on the down we have the camera. Okay, and here I have my object node tree. Here I have my materials. Okay, and if I select, I have my parameters here. Okay, I hope this doesn't confuse you, but I like to work this way. So I have my camera. Let's change the view to full HD. Okay, And let's add some lights. Redshift, let's place a dome light. I'm going to pick up one HDR for our dome light. Like this, I think, a little bit. Okay, let's use this studio. Okay, I'm going to enable background and I want to place one light. Okay, with this selected, let's go here, look through AVS light 1, and I'm going to place it somewhere here. Okay, something like this. I'm going to increase the size. Let's turn off. Let me see the size of that. Okay, so I'm going to increase this maybe 5, 3, something like that. Do I need another light? Let's see first our IPR. So let's press IPR. Again, we didn't change any materials. We are going to work that now. Okay, I'm going to right click always on top and let's start changing a few stuff. So first, for the floor, I want a white floor, but I want the reflection to have really high roughness. The light, I don't like the light there. Okay, so I'm going to change the light position. Instead of being there, oops, sorry, I forgot to lock the camera, the viewport. So I want something like that here. Okay, so I have the light there and I want the light to be bigger and smaller on the Y. Nope, 0.8. Okay, cool. And my dome light is way too... Okay, I think that's cool for the light. Okay, the floor, I'm increasing the roughness so it won't be a mirror. Okay, let's change the choco bar. So this is kind of brownish. Okay, chocolate milk, normal chocolate. Let's increase the roughness, something like that. You decrease a little bit of the reflection. The brown is not chocolate. Let's make it something like that. More brown, dark chocolate. Okay, I think that's tasty. So right now we are missing the jelly. So the jelly, this is the more complex one, but it will be easier. So let's go. I like to start with tinted glass. Okay, we are getting something. And right now I'm just going to play with a few parameters. First, on the refraction, I want to turn off the link to reflection because I want the parameters to be different. So here it's cool. Let's change this to 1.3. Okay. On our refraction, let's make it like 8 to have more power on the refraction. Maybe 8 is way too big for. Okay, that's cool, that's cool. And let's change the colors here. Let me try and understand here one thing. I think if we do this. Okay, just trying to figure out what is doing the scatter. So the scatter, I want a little bit more honey, more orange in other way. And for our transmission, I want a little bit of strawberry. Maybe the scatter is way too big. No, it doesn't look like jelly. Let's change the camera so I can see a little bit better the material and the air bubbles. Always on top. Oops, sorry. So what I want, let's see, something like this. Let's change this to 2. We can start seeing the bubbles here. So let's change something like this. Maybe I'm doing this the wrong way. Okay. Let's increase this to 0.8 to have more power. And our absorption, let's crank this up to 5. And we need more color here. Maybe even more. But I know this should be more like this. Maybe this light is way too strong, or the dome light. Where is my jelly? As you can see, this is a lot of tweaking. So let me try a really high number. Okay, when I turn on the scatter, it is changing a lot. So I need to work with lower values on our scatter. Okay, cool. We are getting somewhere. I want a little bit of roughness here. And more jelly. Maybe I'm going to stay with 2. Oops, let's change. Okay. That's a nice view angle. So I'm still not happy with our jelly. So let's change this a little bit. It looks like poop. So let's make it something like this. And I don't like this dome. Yeah, the dome light was adding a lot of bluish and a lot of light. So let's go back to 1. And our light, let's increase that light. Okay, I'm going to change again to chocolate. Okay. As you can see, the dome light has a really high impact on our materials. And right now, if I increase this to 1, starting to look more jelly. Okay, I'm going to decrease this a little bit so we can see the air bubbles. Okay, let me use almost water. So as you can see, we have our air bubbles. Let me go here, try to increase this window. As you can see, we have our air bubbles. Let's go to a different frame. Let's wait for my Houdini to process. Come on, it's done. So let me press IPR because it is a deforming mesh and Houdini is not redshift can't process that in real time. That's cool. We have our air bubbles inside our jelly. This is really ugly, I think, the materials, but let's go back to our 8 absorption and let's go back to our strawberry flavor. Maybe increase this a little bit. That's look better. Our chocolate bar, I don't like that. I don't like that brown. That looks like poop. Okay. This looks awesome. I like this one. Let's check another view angle. Let's check this one. Looks cool, but our chocolate bar doesn't look like a chocolate bar. It looks like plastic. Let's turn off the reflection. And we are not seeing the air bubbles, but they are here. Look. We can increase the size of air bubbles, of course, if we go to our, where is it, point triangle. We can increase this air bubble size. Let my Houdini process everything. Of course, now we have a bigger bubbles and we have more holes during the simulation, but let's see them in action. Pretty cool. These look like more jelly now. Let's check this. Cool. Cool. Now you know how to create viscous liquids, add bubbles, and render your animation with redshift. Let me know in the comments if you like this type of tutorial where I explain the logic of the project before jumping into Houdini. Hope you enjoyed this one, have a nice day and see you in the next tutorial.